let's see. So we're looking at section 12.2. Let's go to the exercises. So you wanted me to do problem number 37. So maybe I will start with that exercise 37, and then we'll see what we did for the quiz. So exercise 37 here is in the section 12.2, right? So it gives us a sample and it wants us to find so-called mid-range. Well, that's something that we didn't really do, and that's not what you want to worry about, but let us still mention what range is and what middle of the range is, because that's something that we're going to work with anyways. So that's a problem in section 12.2, right? So it turns out when you have your sample that starts at the smallest and ends at the largest elements, then the difference between the largest and the smallest is called as a range of the sample. And then mid-range will be half of range. So that's all it is. So mid-range will be like point in the middle. So let me find the range first and then see what this means to find a mid-range. So the smallest element in this little sample is 1, looks like, right? It starts at 1 and it goes all the way through 8. So if I subtract numbers 8 and 1, I'm gonna get 7. So once I have 7, then how can I find the point in the middle here in the center of my sample? Well, it turns out that what I want to do is get this smallest and largest averaged with each other. So I'm going to do the following: smallest plus the largest and get the average. So that's how we find something like a midpoint, right? So center or middle of the range or midpoint of the range, which is 4.5. So it looks like this is something that you probably already saw before, find a midpoint, but they gave it a different name in statistics class. And that's why you might feel that what is going on, so what is the mid-range? Well, we already saw the idea of range previously, right? But what's in the middle? What's the mid-range? Well, it's just a midpoint, the center point of that little interval. So now the question is, how about quiz? Remember what we had for quiz last time?
27.
27.
Yes.
Thank you. Thank you. That's great that you remember. So I asked you to find a mode, right? For that particular sample, what was the mode or the most popular sample element here? And looks like when I go through the sample elements, I notice that number 95 appears here twice. So my mode will be number 25 or 95. So since it is most popular sample element, then we have a mode like that. Well, what else did we do here? It turns out we also found so-called median. So let me try to get a median just to recall how this is going to be done. So I'll take a look at the sample. I can, same exercise, 27. So let me try to rearrange this data. The smallest is 91. Then next is 93, right? Then we have 95 that appears 2 times. So it's 195 and also another one, 2 95s. Then what? Then we have 97 and 99, right? So it looks like the total number of sample elements here is 6. 6. So how we find the median? So I want to find median for the sample just to refresh another popular finding from this story of samples. And the way to go will be to use n plus 1/2 that gives you position of that element. So I don't want to put equal. I just want to, first of all, find so-called position. So this is going to be 3.5, right? So it tells me that in between of 2 elements, 95 and 95, I should find the median. So what should stay in between of these 2 95s? I say, well, Alex, that should also be 95, right? Because it is average of 2 of the same numbers. Both of them are 95s. And in that position, 3.5, the one that I just successfully calculated, we can look at 1, 2, position number 3, right? Position number 4. And in that, in between of 3 and 4, there's a 3.5, and this is my element. Okay, so it looks like we have found it, and let's see what else is here. So since I told you not to worry about mid-range, so maybe you should not worry about the exercises here on this page. It's technically not very hard to find, but I don't think we are using it, the word mid-range, much. That's why I didn't really worry about that. So when I turn the page, I see that the practice plus story starts. So the section is over, and that's great. So we can see what else appears in this nice chapter. So I'm gonna go to 12.3 to continue the story of our samples. In fact, here's the word range that we just saw, already calculated, the highest and the lowest data values subtracted. When I say, how come it's in the section 12.3, we already talked about it. Well, the reason is we have one big story about the samples, and that's really all we are dealing with. Now, here's the little bit less pleasant formula appears, the formula for standard deviation. So what does that mean? One can take a look at this formula and wonder, how come they have it here? And what does that really mean to find the standard deviation? And I think I need to tell you a little story about standard deviation so you start to understand how this formula actually popping up. Because we know that this sigma, right, means a sum. So I have to add some kind of differences, right? And they're squared and then divide by n minus 1. So what is this all for? So what I think I'll do is share a blank page with you so I have some room and we can actually understand what this standard deviation story is all about. So I'm looking at the sample with, let's say, 5 elements, 1, 2, 3, 4, and 5. And what I'm going to do is find the sample average, sample mean, by adding these 5 elements together and dividing the sum by 5. So here's the way to find sample mean. Remember, the average. So when I do this, I'm going to add these 1 and 5, 6, and now 6, 12, 15, divided by 5, I get 3. So sample mean is found, the average. I can look at another sample with elements such as 1, 1, 3, 5, and 5. So I deliberately want to have that second sample have same exact mean. So if I find a sample mean, the average for that sample, I will add a pair of ones with a 3 with a pair of 5s and divide the sum by number of elements, which is 5. And it's also going to be 15 divided by 5, which is 3. So it looks like I have another mean found. Well, then what? Well, then I want to calculate the way the sample is spread. What does this mean? Well, let's take a look at the picture of my sample elements. So sample mean is here. The elements are something like 1, 2, 3, 4, and 5, right? And the average is right in the middle. Well, if I look at how far the sample elements are from the mean, so if I look at so-called gap or the difference here, then I'm going to have something like 1 here, and difference between mean and 5 will be 2, right? And another gap is going to also be 1, and between 1 and 3 is also 2. So what I can do is calculate those differences between my sample mean, which is 3, and every single sample element, let's go 1, and then 2, and then 3, and then 4, and then 5, right? So there are 5 elements, so I see that I can find the distances in between the point, the sample, and sample element, and the sample mean. And then I can find the average of these distances. So what I can do is add them all together. And to try to average, since there are 5 of them, I will divide this by 5. But please notice that when I start to calculate those differences, what I'm going to get is a -2 here, -1, 0, +1, and +2. So if I decide to add all of these together, then the result will be 0, right? Because -2, -1, and +2, +1 will cancel. And that's the problem. So I don't want it to be 0 because definitely the gap is not 0. So what people do is make them squared. So they negative signs gonna disappear. So each difference I square, So I'm gonna square this and this and this and this. And when I square, it's not gonna be correct result. So then I'm gonna have to also do the extraction of square root, see? So when I calculate the square root from 2 squared is 4, right? Plus 1 squared is 1, plus 0 squared is 0, and then another 1, and then another 4. Then divided by, they say 5 minus 1 in that formula. When I divide this by 4, then what I'm going to get is a square root extracted from 10 over 4, which is like a square root from 2.25, and looks like it's about 1.5. And that's exactly what we can see intuitively when look at the gap here, which is 2, and here, which is 2. And in between those closer numbers, the gap will be 1, right? So the average is in between 1 and 2, which is indeed 1.5. So in other words, what I'm looking for is how far sample elements are spread away from my center, how far they're spread away from sample mean. So I can analogously do this same procedure. So what I can do with the other sample is also take that sample mean 3 and subtract it from each sample element. So I'm gonna take numbers 1, subtract 3 and square, and then add it with another element 1, right? Subtract 3 and square. So what are the elements? They're right here. Maybe it'd be better that I put them in the picture like I did with the previous. So the sample mean is here 3, and my sample elements are 1, another 1, 5, right? And another 5. So it looks like that we are going to have the distances from center, from mean to each element equal to 2, right? And same on the other side. Here is also 2, and so is on the other side. It's also 2. So it looks like we have a bunch of distances, and they're equal to 2. And the average is probably also going to be 2 because they're all 2. And we can visualize this right now by doing this calculation of so-called standard deviation. So I take from 5 this 3, and then another 5 minus 3. Please notice that's how I produce the 2's, right? If I say, Alex, why did you do this? I can see that average is 2 right away. Well, I'm trying to arrive the idea of that formula. So notice when here I calculate these differences, so I'm going to have like a minus 2 squared, right? And another minus 2 squared, and then a 0 squared, and then we're going to have plus 2 squared, and another plus 2 squared, right? And when I divide all that by 4, then we're going to have something like 4 and 4, and then 0, and another 4, and then another 4. So when I add all of them together, so we're going to have 16 divided by 4. Well, this is going to be a square root from 4, which is 2, just like we were thinking. So it turns out that thing that we calculated is called standard deviation. Standard deviation. Special name that, well, we'll get used to a little by little. So they call this with letter S. That's not surprising. It's a standard deviation. And they produce the formula for it, for standard deviation. So they say that it is going to be a square root that we extract from, and denominator is sample size minus 1. So what we had in numerator? Well, we take elements of the sample and we subtract sample mean, the average, right? And then we square it. And then we add them all together, so we put a sum. So that's the reason for this formula that is definitely not very pleasant and quite tedious. But what it does, it tells you the ballpark for your sample elements. It shows you how far from the center, from mean, your sample elements are actually spread to the left and to the right. So how far are they from the middle? How far are they from the mean? So how far they're spread from the left and from the right? That standard deviation thing is what it is all about. And that's interesting, right? So looks like we're gonna have this formula utilized in the section. So I wanna now switch to share that new screen here and go to the actual example where they do this calculation. So please notice that's calculation of standard deviation is pretty tedious, right? Because you have all these sample elements and then you need to subtract and then square and so forth. And that's why I don't really like to do this. You say, what does this mean? Are we gonna skip this? No, not at all. We can find a nicer way to get the standard deviations. That's what I'm trying to say. I'm gonna use technology for that. What I'm gonna do is show you today one very interesting way to find the standard deviations using so-called standard deviation calculator. So when you dealing with standard deviations, let's say if you have a sample here with elements, let me write them, 17, 18, 19, 20, all the way to 23. Oh, okay, so we don't have to copy. I can see that sample A has 4, 6, 7 elements, right? 7 elements. And those elements start from 17 and go all the way through 23. Okay, so looks like we're going to deal with this elements by finding that special standard deviation, as well as they looks like found a sample mean here, like add and divide by 7. But I'll show you the technology way. So I'm going to go to standard deviation right here. So you start typing it, it already appears, but not just standard deviation, but a calculator. So when you type standard deviation calculator, turns out you will get a calculator that will actually utilize this formula. And choice number 1, the calculator that I will use appears for free in Google. So all you need is just to enter 17, then put comma, space, 18, and so forth, 19, 20, 21, 22, 23, right? So those are my 7 sample elements. 7 elements, so here they are. And what I need to do will be to use this calculator. Let me share the link of it here in the Zoom chat so everyone can actually utilize it. So I'm gonna send this message through the Zoom chat to everyone right now. So
Professor, then we need to click on population or sample.
Well, let me just wait, just patience. First, I send it to everyone. And since we are dealing with a sample, we need to click on the sample. And that's great that you noticed there are two choices. One is for sample, the other is for population. So we use sample. Why? Well, because we have a sample size 7 here, 7 elements. So I don't think anybody ever uses population. It's just the calculator designed this way, but sample. So we calculate sample standard deviation. And in order to calculate, you just click on this calculate. And once you did it, once you click on the calculate key, oh, I think I put this dots. I should have put commas, right? So I wasn't careful. That's why it doesn't calculate. It just wants to put commas. Make sure you put commas, not the dots, right? So commas after every entry, and then you click on calculate, and look at that. You found the standard deviation fairly quickly without going through all this process. So you can record it. Your standard deviation for this sample is 2.16. And then there is more, 0 to 4, ... sample standard deviation. And also sample mean, which is 4.6666 ... So I calculated standard deviation without using the formula, but using technology. So what you can do is try to get this calculator and enter sample elements in it, and then click on calculate. But yes, indeed, if you put population sample, it's important to make sure you select sample. So once you calculated it, you got yourself not just standard deviation, but also sample mean. So when you say, Alex, I could calculate averages also with this. Yes. So I was holding this from you till right now, because it looks like now you will definitely enjoy the fact that you do have this sample standard deviation instead of going through this entire process of calculating this differences, squaring them, and then adding, dividing, and eventually getting same exact answer. Well, I think it's much more fun just to get the result right away, isn't it? So let me try same thing with a sample B, so we'll get used to this little calculator. So once again, I just send it in the Zoom chat to everyone, the link. You can click on that link and it should open for you. It's a free calculator for standard deviation. So let me see what elements this second sample has and find the standard deviation for it as well. So we have 5, 10, 15, 20, 25. So they all differ by 5, right? And then we have 30 and 35. Okay, so another little sample is here for us. The number of its elements is also 7, right? So we have another sample. And then let me go back to my calculator. And then I will re-enter data. So let me delete all of these guys and put the new sample, but make sure you put commas. By accident, I put some dots, and you want to make sure they're not dots, but commas, right? 25, 30, 35, and this is it. So again, make sure you, instead of population, you select sample, right? And then click on calculate, and there you go. Here's your sample standard deviation. It is 10.8 something. And also there is a sample mean for this sample, which is found as a one right here. I hope you can see it. Let me scroll this a little bit so you can better see it. You see that sample mean here is number 20, right? You see the 20? So sample average is 20. So what does this all stand for? Let us make a little bit of a sense. So when I'm looking at the first sample, sample A, that runs from 17 through 23, then we found that its average, the sample mean, the sample average was equal to what? Let me double check that because I don't think it's 4. I don't think I wrote it correctly. I think it's something like 20 or whatever, right? So let me double check. I just did it, but I think I deleted it. So let's see. Here it is, right? So calculate. So sample combo. Why did I put those points? Huh? I don't know. I just put the points. So we had a sample mean of 20, right? I just wasn't careful. It's 20, not 4. I just want to make sure I put it correctly, right? Sample mean is 20. Oh. So it looks like they gave two samples that had the same sample average. So in this first example, the sample average was 20. And then they said that standard deviation, so-called ballpark, the ballpark standard deviation was equal to something like 2.16, right? So if you go by 2.16 to the left side and by 2.16 to the right side by your little standard deviation, then you're gonna pretty much cover all of the sample elements, because if you add 2.16, it'll be like 22.16. One say, Alex, but there is element 23. Yes, but it's all giving you ballpark. It's approximating where your sample element's supposed to be. So if you have this subtract 2 point something, it'll be like 17.84 or something. And you can see that it's 17 is well close, pretty much in the ballpark of that sample. That's the idea. What about the second sample? Well, the second sample has more elements in it. So we have the 20 also, it's mean, right? But we also have 25, 30, 35 on this side, as well as 15, 10, and 5 on the other side, right? So we also calculated these standard deviation for another sample. So sample mean was again 20, but the standard deviation for it was 10 and little something. So if I put 10.18 here, right, standard deviation like 10.18 on one side, and a standard deviation again on the other side. See, it gives you the spread. How far from sample mean should I expect my elements to be? Then notice, yes, again, couple of elements here, 5, and here 35 are a little bit out of this, but technically the sample is pretty much covered now. So we know that the center is at 20, but to the left and to the right, we don't go like in the previous little sample only by 2, but now we have a bigger spread, 10. See what standard deviation actually tells you? How far those elements could be around the center. Are they spread a lot or not really? And well, it's good to realize what standard deviation stands for, because you may have the same exact center, but elements may all be stuck around it, or they may be far, far away from it. And that's definitely making totally different picture for our samples. So let me try another exercise in this section, just one of the exercises, because it looks like I'm not going to have time to give you a quiz today, but that's okay. We'll have one next time. So let me go to the exercises and find one question that wants to get a standard deviation for some of the samples. And we'll actually use the calculator and find it. Let me get some like not very nice looking sample, like exercise number 10, for example. So in exercise number 10, they say, look at the sample with elements, a couple of 60s. Then we have 62, 260, no, 365s. Look at that. 365s. Okay. So 3 of these guys. Then we also have 66, 67, right? And a pair of 70s, Okay, so I got these elements in my sample, and this is great. So how many of them are here? 2, 4, 6, 8, 10. So number of elements in the sample is 10. Did I copy it right? Let's check. 2, 4, 6, 8, 10. Exactly. Okay, great. So let me go to this standard deviation calculator and to enter those elements in it. I want to clear the mess a little bit. There's just too much of writing around it. So let me clean this a little bit. So better see what is going to come out. So let's do it. So how would you do this? Well, first of all, delete what you have here, right? So you put the 60, make sure you put commas. Then 62, actually pair of 60s, right? Then 62, pair of 65s, actually 3 of them, 3 65s, right? Then we also have 66, right? And then 67. And also 2 70s, 70 and another 7. And that's great. So I still have it on the sample, and I click on calculate, and there you go. It doesn't take too long, right? Standard deviation for this sample is found. It is 3.5590, maybe enough. Please notice that I also have sample mean here right away. It is 65. And looks like that's what they already gave us in the exercise anyways, but they didn't really have to give us sample mean. I know they're nice, but we can get it ourselves anyways, right? So I just found the standard deviation for this sample, and that's really all we needed in here. So that's really all I need. So I found standard deviation. So at this stage, I guess I'm gonna end it for today. As I said, no quiz. It's not much time left. And if anyone has any questions related to the class or whatever you were wondering about, we can discuss that right now. If anything you want to discuss with me, you can do it in private way. If most people log out, and we can talk if anything you want to talk about. And if not, well, then have a great day we'll meet again on Friday, and we'll talk more, of course, about the standard deviation, the calculator. Yes, you want to get used to this calculator, because otherwise you're going to be stuck with those tedious formulas, and it's going to take you, believe it, like probably 20 minutes for this exercise to do all this little calculations. But with this beautiful little calculator that I found for you, absolutely free online, you can just get standard deviation calculated right away. All you need is just make sure you entered all of those numbers and commas after those. So have a great rest of the day, and thank you for coming over. Bye-bye.